Here we're going to deal with what we call difference of squares. Now, once you get into high school in grade 9 or 10, you're going to learn about difference of squares as it relates to algebra. But now we're just going to use it as a means by which we can multiply. And the whole idea between difference of squares is that people learn their perfect squares first. That people know what 10 times 10 is and what 8 times 8 is, and before they learn their other basic facts of multiplication. And if we can use what we already know to build upon our knowledge, then all the better. Here we can see that if you're just learning your multiplication facts and you have a problem trying to figure out what 3 times 5 is, if you can recognize that these two numbers are separated by 2 digits, so that there's a middle number, and in this case, if you were counting, you would go 3, 4, 5. And if we take the middle number, the 4, and square it, so 4 times 4, that equals 16. Now, if we look at these two equations and the two answers, there appears to be something happening here. Now let's take another example where we have 7 times 9, and let's assume that you don't know what 7 times 9 is yet, but you recognize that 7 and 9 have a middle number. If you were counting, that's 8, and 8 times 8 we tend to learn very early is 64. And now look at this, 7 times 9 is 63, and we can start to recognize a pattern here. And indeed the pattern is that when you take the middle number of a multiplication question that is separated by 2 digits, so again 7 and 9 are separated by 2 digits, the middle number is 8, square it and subtract 1, you get the original answer. Now let's try a couple here. Now based upon what we learned, if we were to say what is 11 times 13, that's probably something that you can't right now do in your head. But if you fall back to your previous knowledge here, and we recognize that there's a middle number here, what's 12 times 12? Everybody knows that. You take away 1, and the answer is 144, subtract 1, 143. What's 19 times 21? We don't necessarily know that in our head, but we can recognize that there's a difference of 2 here, so we take the middle number, which is 20. 20 squared, so 20 times 20 is 400. 400 take away 1. The answer of this is 399. And then, of course, we have some more complex questions that certainly you can do in grade 7, where we have 199 times 201. And now we're going to be able to do that in our head. By in our head, we're allowed to take a couple of little jot notes, and I've done so here. So we take the middle number. We've recognized that there's a middle number, 200 squared minus 1. And 200 times 200 is a little trick we learned pretty early in school, is that you multiply the first 2 digits, the 4, 2 times 2 is 4, and then you add as many zeros as there are in the question. So 2 here and 2 here, so you add 4, that's 40,000. And then take away 1, so the answer is 39,999. So 199 times 201 equals 39,999. Here's another example. If we take 95 times 96, we notice there's a middle number, 95. What's 95 squared? Oh, now in order to figure that one out, we're going to have to rely upon what we learned in a previous presentation that was called multiplying 2-digit numbers. And we recognize that this ends in a 5, so 95 squared, that indeed it's going to be end in 25 when we complete it. And then you take the 9, so there's the 25 that it ends in. Then you take the 9 and you multiply it by the next consecutive number. That's the number if you were counting what comes after 9. So 9 times 10 is 90. So the answer is 9025. And then of course we have to take away 1. So the answer to 94 times 96 is 9024.